Hello, everyone. Welcome back to the broadcast. Hey there, James. Welcome. We're finally getting back into it, trying to get that momentum going again, folks. Sorry about all the delays. We are going to be kicking off some further kind of redesign work on how we had movement working. So before, what we had was a kind of left to right flow of movement types with the positioner types happening at the time of spawn. So if I had anywhere in the chain, like split into 3, split into 5, we do split into 3 and then split into 5 right at the beginning. It would end up being effectively 3 overlapping split into 5s. Little bit of variation there, but for the most part. And then it would merge all of the movements together, accelerating based on the number of movements in it. I don't know if we're going to keep the acceleration, the extra movements that are happening, but we are going to change things. Did some spitballing with some folks, and I've come up with a new design for it. So before we get into that, I've got a crude diagram. Let's check in with the kitties here. We do have, I didn't get that blanket perfectly, but we have Sky on the gray blanket. We have Mason on the tan one. We have Ember across from the keyboard in her spot. And then we have Sammy over on the shelf. Everybody's cozy. I think Sherbet is kind of to the right of Sky, at least in the perspective of that camera. Let's switch on over here. Okay, not 100% visible. So previously we had our inventory like this. So you'd have like your little weapon icon and you'd have a series of slots. Still going to have that. Weapon slot, still special. Each one of these is just going to be the raw icon. Whatever the behavior, our new term, whatever the behavior is, will be in that slot. Now, some of these will have a trait called a gate on them. That might be something like after 3 seconds when it hits an enemy, that kind of thing. We're going to start with the after X seconds. So as far as behavior goes, we always execute whatever the behavior of the weapon is. Always do that. So the homing mouse will always have an aspect of the homing mouse to it, no matter what follows. Then what we're going to do is, starting with the weapon behaviors, we're going to go through the inventory until we hit one of those gated ones. We're going to take everything before that and we're going to lump it into what I'm going to call a segment. It's just we're just kind of remaking a new behavior that contains other ones. The first segment that contains the weapon, we're calling the base segment. This one always exists. It never goes away. So if I have a couple of extra movements without gates, extra behaviors without gates here, that will become part of the weapon for that particular projectile or enemy. Then for each one that has a gate, the gate starts a new segment. So in this example here, the circles are gates. So we have the weapon in the first 2, then the next 3 are in a group defined by the first gate, and then the last 2 are in a group defined by that last gate there. So we have these groups, and then we create 2 parallel lists. One that contains the corresponding gate, and one that contains the segments here. So workflow-wise, when the entity is told to act, is told to move, or do its thing, we start with the base segment, execute the base segment. Then we check the next one and say, is its gate open? If its gate is open, then we're going to proceed into there. We may check some of that, but we're going to proceed into there. If it is coming out of a segment that is not the base, so if it's not the first one, let's say let's say we get into the second one. When its gate opens, we deactivate the prior one. So if the first one is, say, after a second and the second one is after a second. So we do the base segment, and then we check the gate. Hasn't been a second yet. We keep doing that base segment until that second passes. Now the gate opens. The prior segment is the base segment. We don't do anything extra. And we proceed into that new segment. Then we check the next segment. Well, upon checking the segment, we pass this delta into it and say, has it been enough time? Might have to check that as far as the timing, but has this been enough time? Once that next second passes of executing the base segment in the second one, this gate opens, which means we go in and we deactivate this middle segment. It stops happening. Now, when we iterate again, we do base segment and then the second non-base segment, the third segment. And it will persist in that way until the projectile goes away. This is our goal because, like I mentioned earlier, one of the things we can do with a gate like that is have the gate react to a collision event and say, hey, a collision happened, this gate opens. I'm not 100% on exactly when we handle gates opening or closing. I might have that be a precursor step. Yeah, James, akin to that. We have a series of conditionals and what results from them, The sequential nature is going to let us do things like explodes on impact. It's going to let us do things like keep dropping other ones for the duration of this step. We'll probably have up to a limit on spawn other ones so that we don't get into really crazy infinite shenanigans. But we'll see. Like I've said before, we want to get out of control in a controlled fashion. So we want to reach seconds per frame, but we don't want to reach crash because of memory overflow or similar. We'll see on that. But that's the workflow that we're going for. That's where we're aiming. That, close you. So I have prepped this. We're starting into this. There's more that we need to do yet. So this is a behavior object. Core function is act. Whatever it's going to do, it has the entity that it is acting upon and how much time has passed. We have the concept of active. If it is not active, act will not be called upon it. Now, in the case of a segment, the whole segment goes inactive when the next gate opens. But there's nothing stopping within that segment, even within behaviors themselves that act as like combos of behaviors. There's nothing stopping one of them from going inactive. And the kind that is going to most commonly do that are the ones that used to be positioners. So it might be after a second, we enter the next segment. At the start of that segment, or somewhere in that segment, we have split into 3. as soon as that happens, it's not going to happen again. There might be some super version later that splits more often, that kind of thing. That starts to get really risky as far as entity generation rate. Exponential increases like that. But it would stop happening. It deactivates itself. It could be both, James. It could be both. You could have raw seconds, like however long the projectile has existed, which you need to pay attention to if it's a short-lived or particularly long-lived projectile. Like, what does that mean for its lifespan? If it's very short-lived, then, after 3 seconds might be after it's already gone. And that's where some of the build comes in, is figuring out how do I order these things? And is this one useful at all? But there's also the possibility of percentage of lifespan. You could have, when we're checking the gate, one of the things I want to have it is just like this act function. Pass in the entity and the time. Is the gate open? One of the things that it can check based on looking at the entity is stuff like, does it have like X hits left? Has it penetrated one target? Has it passed through at least 25% of its lifespan, kind of thing? That could result in cascading gates opening, and things jumping to the end, that kind of stuff, very quickly. But it should still be interesting. Okay, so we have that. So here we have our gate key. If this is populated, then it is gated. What the gate key is it's the catalog key. The behavior itself does not use the gate. The gate will query the entity itself. It will check other things. But it will not... we don't load the gate until we discover it, until we make a segment out of it. So that's why we have gate key. It is currently specified when you create the behavior. This is another pattern that was workshopped after our last stream last week. We have created a interface that is catalogable. And what that does entirely is it has a copy constructor. And what we'll say is like, oh, it's a catalogable behavior. So, T is now equal to behavior, and it expects a catalogable behavior to be passed in. Then when we look at something like the behavior, we could go in and copy stuff. So, like in this example, we have gate key is equal to copy dot we know it's a catalogable behavior, so it is a behavior. We're going to store it off in a temporary here. If we have more things, then this becomes more valuable. We will be getting to that. This serves two purposes. It is a mechanism to get it from the catalog cleanly. Look at the catalog. Gotta revert the movement ones. We have sunset the concept of movements. They're going away. VS Code is free, but it's missing a lot of quality of life stuff that you can get out of Visual Studio. I do have a license for that, but I haven't, updated it. I'm not paying for a new edition just yet, kind of stuff. Let's see here. We should have a copy function in here somewhere. Can I store that? I must not have. Okay, we can. Parsing this. Here we go. So in getTargeter, we have we're calling activator create is instance the type of the object that we've retrieved, if we've retrieved something, and we're passing that object in. And that's where the essentially the copy constructor comes in. Is we're instantiating an instance of the thing that we got of it. We're instantiating something of the type that we got, and we're passing the thing that we pulled in to duplicate. So in the case of behaviors, we're going to call into this, and it's going to copy over the gateway key. We're going to have lifespan, max lifespan, that kind of lifespan left, max lifespan, all of the constituent behaviors in it. That kind of thing will also be copied here. And part of copying them is going to be things like get their key, that kind of stuff. Okie doke. Let's get going on that. Let's rip the movement stuff. We'll take this in waves here. So we have a copy method. We don't want it to just be in getTargeter here. That's going to be, if we get something, set it to the copy. So we're not going to put a where here. Oh no, we need to have a where. Because we need to know which collection to pull it from. Okay, so stop being helpful. There we go. Okay, so this is for targeter. We are going to be able to converge on this. This one will return a targeter. This one is going to be a catalogable T. No, it's going to return a T. Going to instantiate a copy, and we're going to pass in an iCatalogable. That. There we go. All right. So then what we're going to do is we have to instantiate. Now if we go into get targeter here, we're going to do this right here. I think there's a non-null marker here that we can do. But, no. Do that. How are we going to do this? Don't know if we can do that. Okay. So, we have a function that returns type T. It is a template. We have type T in here. It takes in an iCatalogable of type T called toInstantiate. And T itself is an iCatalogable of that type. So we already know that. We already know that. But we're ensuring it here. So then for each one of these, we need to set up what collection we're pulling it from. And that is entirely just knowing which one of these. So we can have a series of them that are type specific. And then in this, instead of... we're still going to need to call into that. The thing that I don't want to do is have this repeated over and over. Because this is always a dictionary. So we're going to get one of these types out of it. Okay, so in instantiate copy, we're not going to do this. We are going to say, instead we're going to have a dictionary type what here? String and then the thing that we want. So that's the dictionary. Then we have string as key. There. What's the syntax for that? Not null. We need that too. Yes, coming together, coming together. So I thought this was another where case, but I did this elsewhere. Using, okay. Yeah, there we go. That. Using anything from Godot in here? Yeah, we're using vector 2s. We don't have to, but it's very convenient. Check something. Always interesting when you get those Reddit posts that are like, "Oh, you should just do this." It's like, no, that's completely not what was being asked. You are calling out a way to redesign and circumvent the problem, but that won't solve the problem that was originally broached. I mean, if you can do things cleanly in a way that avoids the issue entirely, that's good. But sometimes you can't walk around it? That's not the question. There we go. Obnoxious. So, let's. There we go. Okay. Because we are avoiding talking to Godot in as many ways as we can. It's equal to dictionary.try value Yeah, that's the trick, Tess, is I don't... It should be in the val. It should be in it. I should never be referencing it outside. And I think it's okay to crash if I've screwed up the internal system like that. Okay. Also, hello, Taz. Okay. So we've got a cataloged value. If the cataloged one is not null, I'm going to do that. I actually tested this. I don't need to keep the types around. Like, I don't need a separate collection of types. This is actually going to get the type that was instantiated during the loading process, which is convenient. Now, I could just pass in T there as well. Because I know that's what this is. This is a type that it wants. This would technically be more concise, wouldn't it? Type of the actual class. As opposed to instance.getType. Okay, so we're going to have multiple of these. It's not copy here. This would be used if it's a get. Okay, let's see here. This one is... It'd just be private. Could pretty much be this here. We're cooking here. Okay, so get from catalog is going to get me an instance that I'm going to then copy. So it is pretty much just this. So we have a shorthand here where the copy function can specify, hey, use the targeter one. This will get the copy, and then we are going to tell it to instantiate that copy. Oh, well, I'm sorry. This will be used when we get it from the catalog later. This will be used when we have a copy to use. So in this case, instead, we are going to be using... Hey there, Chloe. Welcome, welcome. We are going to pass in we know that it will have the instantiation constructor that we need. So we're going to have to instantiate here. And this is going to be a type T. We're working on essentially the preloading system where we've got all these objects defined at startup, and then in the code we can reference them. And one of the things we have to do is that we need to create a whole new reference that is a copy of the one that was in the catalog. We can't just use the one in the catalog because then they'll all be the same thing. Like the same entity. So instead, we're coming up with this duplication logic. So we need a source dictionary. And that will be based on the type. We're going to get a thing of that type. T can't be null, and it has to be an iCatalogable. Okay. This is correct. So then in the instantiate copy, we don't need a key. And the instantiate needs to be non-null and a catalogable. It should be there, though. It should be there. So this is not necessary, but we're going to have it. That way we have a very specific error. You tried to pass null into this. Okay, so we have to instantiate here. We start with a null. We know it's not null. Okay. So we could just return this. So when we copy it, we're going to use... Trying to figure out if we could make this more concise, but I think copy for each type is still viable. So in a copy, we just instantiate copy. So we're going to call instantiate copy targeter, and we're going to pass in the to copy that. This case, we can just use T here. With that. Is iCatalogable T. Okay, okay. Looks like that isn't necessary for it, because this will always be the T that is that one. I'm going to leave it. It's explicit. Okay, so if we copy, we just instantiate the copy. We just call this guy. If we're calling to get one, that's when we need to know so when we call get targeter, we're going to have a string for the key here. So we're going to pass in to get from catalog. That will get us our cataloged one. Targeters and key. So this gets us the cataloged value. So we have that. Then we are going to just straight up return a instantiate copy of a targeter. Pass in the cataloged one. Again, this is unnecessary because we're passing it. We know what, in theory, we know what that is. I don't care. So this is the part that makes it so we have to have, that we would have to have multiple of these. I could abstract this further by having a function that says, get me based on this type, and then have like a little switch in there. Well, a cascading if. Let's... I'm always going to needlessly over-engineer this stuff. It is the way I am. Okay. Getting from the catalog can directly instantiate a copy. Okay. Catalog. Just temporarily get it to stop whining at us. Source dictionary, we can determine. Okay, so then we have this. Move you. Just have a string key now. Okay. Ooh. No. I don't know if this is the best way to go about it. But we're going to roll with it. We're going to roll with it. Behavior. Targeters will be embedded in behaviors still. The most common thing is going to be, I think, a behavior. Because we will clone these, but we're going to clone a whole bunch of behaviors. But should work. Can't explicitly convert this. What can we do here? We don't need source dictionary. We don't need that. We don't need that. We just need cataloged. Hey there, Borna. Welcome. Now, I think... And hello, Amancio. Welcome, welcome. Okay, how can we do this? How can we do this? So what we want to do is we want to be able to determine which one of these that we're using. Because I could just explicitly have a get targeter and still pass in a source dictionary. We could pass in this. I think we have to. Pass in a source dictionary. So we get that, and then we're going to return instantiate copy. You are joining us for a rewrite of the way that we do the movement logic. It's going to impact how we spawn things, and it's going to create, I think, some interesting flexibility in the sort of movement patterns we can create with our projectiles. Should be pretty cool, but a lot is going to happen between here and there. Okay, so we need to get the source dictionary. So when we call get on them, copy we can do. We're going to have a get on each one, and we're going to pass in to get from catalog the relevant yourself. So I still need a get for each one, but every other piece from this is pretty clean. Okay. So we're not going to have movements anymore. We're going to have behavior. See all this red? It's really upset with me. Wow. We need to get on that. Then we're going to do this is equal to behavior. We need a get behavior here. Load. Up here. Up with the get functions. Pretty much the same thing here, but we're going to use texture wrapper and use textures. Texture wrapper needs to be made catalogable. Wait. No, we're just going to do... This is a special case. This one's a special case. Textures don't get remade. We just use them by reference. Static behavior. I really want that to start with an N for reasons. Behavior. Pass in behaviors and pass in T. That's not right. Behaviors does nothing currently. Okay. Because we need to get some of them to exist first. Sneeze. Okay. So some of these are going to have to change. I'm probably going to move these constants, even though it's nice to... It's proper to have them up at the top like this. I'm probably going to move them down near their functions. We'll see. We'll see. Because I don't have a good way to jump back and forth between the methods and the constants that where they will be where they'll be used. You know, and code legibility. All right. Yep. Position. Entity is going to have two things. Well, no, I think we can just do a list of behaviors, with the 0th one being the special one. No, I think we're going to have... Just in case, protected... I feel like there's a probability, or a strong possibility, that we are going to, what would it be? We are going to eventually have child classes of entity. So we're just going to throw protected on there. I feel like I don't have to, but, you know, it's one of those something tells me. An entity will have its list of movements and its source behavior manipulated. So I'm going to do public. This is a list. No, this one's not a list. The base behavior is a single behavior object. We'll have it'll have a get set. Then list of behaviors, which are we only need to get it because it's a list. We can manipulate it once we get it. Okay. So there are no movements. There will also be we need gates there. So the entity will do nothing for the time being when it's constructed. So an catalogable entity. So that we also want public. Too bad. Let's see, we have an example of this in Targeter. Get this. Then in this method, we're going to call catalog.copy the entity type. And we're going to pass in to copy No, we have a copy. We have a copy. That is, we're saying copy this one. um, Texture key. To copy. Position to position, then this is where the copies come into play. This here. We'd have to have it in there, but we're calling into an alternate constructor, which you do that. Might be a way to accomplish it. We're going to deal with this first. Initialize. Okay, so now we have, we make sure that behaviors exist. It has this list here. Then each here. Not behaviors. Okay. Behaviors. Not add. Catalog. Dot copy. Behavior. Behavior. Okay, so we are duplicating behaviors by doing this. And this is kind of the pattern that we'll use. Anytime there's an internal object that needs to be duplicated for the copy, this is where we're going to end up doing it. So inside of a behavior, when it's duplicated, it's going to create a copy of the targeter that it has, that kind of thing. So then instead of calling this move, we're going to call this act. Just like the behaviors, we're keeping that pattern here. There will be no previous targeter. We'll get there. We'll get there. So instead of there being a previous targeter, there's going to be a public entity, target entity. Set and a public vector2 target direction. Oh, there was a period where I could data entry style type, and then I started programming, and that went away because programming uses like weird symbols and patterns that don't line up the same way I learned to touch type. What that means is while I'm streaming, given the given my bad posture, the camera and like extra buttons in the way, boy do I typo like crazy like that. Okay, so the reason we have target entity in direction here is target direction, target entity and direction to 0. Is as these behaviors iterate during act, they're going to receive the entity. And the targeter will receive the entity. The targeter is going to potentially look at these and accept them or drop them. And after it has taken action on them, it will set target entity in direction to whatever it's using. Apparently, Sky is telling Sherbet it is bath time. Sherbet seems unsure of how to react. Okay. Have that. We need the concept of a gate. If I need to make these partial classes, but whatever. Gate is never just a gate, just like an entity is never just an entity. A targeter is never just a targeter. A behavior is never just a behavior. There should be a suggestion for this. That. It is only abstract in the sense that you don't implement it. We're still going to populate that. Okay, and this gate... Okay. Click. Boolean. Open. Say get. Open. Okay, so what gates are for is to control flow through the behavior chain. Like we mentioned earlier in the stream, we take the inventory associated with a particular weapon and we're going to convert that into little clusters of behavior, little sequences of behavior that we switch between based on the next gate to open. So we do the homing mouse thing, we check the next gate. If it's open, then we proceed into the next thing. It's probably going to be next time we proceed into the next thing. Though there are likely going to be some gates that are upon. So, like, the gate opens based on an event, not just time passes. Which is why I think we should always check the gates before movement. Anyhow. So a gate is open or it's not. A gate can be copied. We're going to put them in the catalog soon. And let's see. Not try. This is open. Is open. This is the abstract. Delta. Right. So this passes in the entity and how much time has passed. a gate will have access to any other world state information that it can reach, but it can look at the current entity and it can look at delta. We are going to have methods in this for handling events. So, like, a collision with the entity happened. All of the gates are going to be told about that collision. That kind of thing, so that the gate could open upon that collision happening, and then we could immediately do a movement with that delta. Or with no delta at all. Primarily, we just want to catch the immediately do a thing style stuff. We don't really need it to move. Which will probably mean we would pass something like 1,000th of a second. Maybe even like 100th of a second. But probably 1,000th. So that, as far as the world is concerned, very little is going to change inside of that thing. But again, this is... We're speculating. Onward. All right. We have gates now. Entities or behaviors don't have a gate, but an entity will have a list of gates. Public? It's one of those days. Behaviors need to be set from the outside in order to load them up when we're constructing them. Same with gates. Because we're going to be piecing this together from the inventory. The entity, this part of the entity is going to be manipulated. Okay, so then gates. New list gate thing. Have enough of him, Sherbet? I was napping. Now I need to come over here and nap some more. Getting a new toy for them to try out. I want to do something with the play area. It doesn't see a lot of action there, so I'm going to try something out. We'll see if it works. It'll be a surprise. Okay, so we've got the behavior, we got the gates. In a gate, we have whether it is open, and we can try to open it. So in an entity, whenever we act... Actually, no. Entity's not abstract. Most things are just an entity. So we have a delta coming in. The first thing that we're going to do is we are going to perform the movement of our base behavior. This always happens, regardless of any gate behavior or anything like that. This is going to happen, and it happens first. This delta. Then we're going to iterate over the list until we hit the first active gate. You know, we could pop from the front on these, but but that would be wasteful. But we're not going to do it much, and this list isn't going to be long. Okay. So again, now we might be actually doing it a lot, not because it's going to be done a lot in an individual entity, but because there will be many, 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 many entities, and messing with their collections inefficiently would be a problem. So we could treat this as a last in, first out kind of thing. We add to and pop from the back. And add to it that way. Because then we can pop the gate and the segment from the list when we're done with it, which prevents us from constantly needing to skip over them. Kind of like that. Append to the end, but is there a better collection if we're going to do that? Not a queue. Be a stack. Be a stack. Yeah. Makes sense, right? Because when we add to it, we're adding to the top of the pile. And then when we're done with, when the gate on the top of the pile is done, we remove that gate and we remove the corresponding behavior. And then we proceed. A push. Yes. Sure. Each gate. Gate in gates. Push. Hopefully this iterates in the right direction. Add each one. Alexa, yes, we're coding. We are writing a game. We're in the midst of a sequence where we're not really going to be able to see what goes on because there's going to be a lot of errors here. Actually, entity manager. That. Writing. So they're not moving right now. We're working on that. This is the first game I've made. This is stream 77 of doing it. Most of the work happens on stream. The amount of work I'm putting into it is accelerating over time. But we're simultaneously learning Godot and relearning C#, all of that together. One of our recent shifts was to get the performance up here as high as possible. Previously, we could only get 2,500 bouncing blobs, and we currently have... the loop is faulty, but, just about 15,000 bouncing blobs there on the screen. And we're sitting at 60 frames a second. Ideally, 15,000 objects on the screen will be plenty. But yeah. Some members of the community are familiar with coding. And so, we bounce ideas in that case. Let's see. Not sure which... Let's double check something here real quick. Okay. I'm not sure which stream James might be in. James is simultaneously doing some development and comes up with some ideas. And Tass is actively helping me relearn C, or C#. Long ago, I did some C# coding, and I didn't for a period of time, and much of the knowledge has rotted. All very jiggly. The rendering on them, all of these little guys are rendered in a multi-mesh. There's a multi-mesh, a Godot multi-mesh. Friend of the stream. James has been watching us for several years now. James was around when we made a Noida mod. Same with Tass. Longtime friend. All of these are done, like the way that they're rendered, we have a texture in a multi-mesh object, but the animation of them, facing, animation, that kind of stuff, is controlled by a shader, which I'm also having to learn how to do. That is the James that I'm talking about right there, Alexa. Excellent. There we go. This is the logic that's spawning all those entities. And right now, this does nothing. Okay. so when we're defining the base behavior, that's where we're going to set something in there. So then we go into the catalog, go to load entities. Don't have load entities. Should have a movement object hanging around, I think. Did I get rid of it? They've already gotten rid of it. Okay. Okay. Shoulder. Gate. Gate into gate. Yes. Okay. Line. Behavior. A click. Straight line. Space. Straight line. A reference. A catalogable. Straight line. Copy. Miss, Sammy has come to sit with me. Come on. Make up your mind, please. For those new, while I'm convincing Sammy to make up her mind, let's see the kitties. So you can't see Sammy because she's walking onto my lap. But we have Sky and Ember across from my keyboard. Sky is the big fluffy gray and white one that is top center if you're in the widescreen mode. And he is laying on, he is using Ember as a pillow. Sitting on the heating pad is Sherbet. He is the sort of mottled tan and white one. And then his brother, Mason, is over on the bed on the tan blanket. Is a much more regularly tan and white pattern. Sammy is a little tuxedo. Skulls. In to copy. States. Ring. We're changing that around. I'm the one writing it within the libraries. I just need to be cognizant of not reaching inside objects, you know? Gonna do that. That'll work. This works. Ends targeter is targeter. Oh, that's a behavior. We do, no, we can only do single inheritance. Yeah, that's fine though. That's ultimately good. Don't currently need to implement these. I'm just going to leave that pattern in place. We'll get used to doing this. Even if they don't do anything, we'll have it in place for initialization, that kind of thing. Have a protected... So I think having a movement type is still valuable. As far as the catalog is concerned, it's irrelevant, but having a movement type could still be handy because there are elements to them. But they all need targeters. Not every movement necessarily needs a targeter. Some movements could just look at the current facing of the object and move in that direction. But from a practical perspective, that's not always going to be the case. There are going to be some that don't care about the targeting. We could have a type that is just essentially keep going, so it would act as an accelerator on the prior vector. Yeah, that's interesting. I kind of like that concept, where not all of them have a target, but it may be expedient for us to still do it, though. To just have the targeter and have targeters that are... Yeah, okay. they should all have targeters, which means folder just move. Yeah, these are still behaviors. We treat them as behaviors. We never, outside of the catalog, we never treat them as anything other than a behavior. This goes into movement. Exactly, Laura, exactly. Triple predator dots for everyone. So we now have a movement type again. Haha. So it extends behavior. Straight line, we're going to take that stuff. Exactly. Movements are going to end up being an intermediary. Because primarily what being a movement is... Oh. Let's go another step back. Is it really a separate class? Because anything that moves... So, if it moves, having a target will tell it how, in what direction, essentially. So, if it's moving a straight line, what's that straight line? The targeter set in what direction. The targeter might say in whatever direction the entity is currently moving, or hold still. Move straight line might be hey, or might be move at the entity. Which entity is it? The player, a monster, that kind of thing. So it keeps the movement generic. But is it possible that the ones that split into pieces could also use a targeter? Most of those, I think, would be maintain the facing, but it could be that each of them would then get a target random direction or something like that. But I don't know how viable that would be. I don't know how useful that would be. I'm going to take my delayed break here. And we'll think on that some more when I get back. And we're back. And I'm trying to avoid situations where we have needless duplication of patterns, especially when they're going to be used in very similar ways. So if every time a behavior is invoked, if regardless of what kind of behavior it is, we always check targeting, then at the behavior level, we should have a targeter and just deal with it there. But if only movement is going to have a target, then we might have an issue there. You know what? I feel like we should give it that option. So we are going to go into a behavior, and a behavior has targeting. Okay. So behaviors can... That's another thing. Behaviors can contain behaviors. Targeter is going to be set. So we don't need to initialize it to a thing. Let's leave that alone. So now all behaviors have a targeter. We can leave it alone and not have it be a generic thing as far as behaviors are concerned. I think the idea of behavior groups are different, and behavior groups wouldn't have a targeter. But that doesn't concern us ultimately, because behavior groups would not use the targeter. It's extraneous, it could be left null. Yeah. Behavior groups we're not to yet. Behavior groups is a behavior that is actually a group of them. Well, a series of them. So, in our flow of logic here, my character lore? Wow. I'm newtmechanist. The mechanist is a title. It is to some extent, an anachronistic term for somebody that works with like robotics and machines. I am the prototype Nyanite, the first model, the first creation in the new line of Nyanite domestic robots by Catbot Corporation. Their prior popular product was the Catbot. You can actually see instances of the catbot in prior corporation broadcasts. After the line was ready to be launched, the head developer decided that it would be a good idea to hand over control of the factory to me and the initial run of nanotypes. And in order to facilitate that, they consensually and non-violently gave me access to a mental scan of them so that I could use that engram to properly run the factory. Then they went on vacation and didn't tell anybody and broke their phone, which is something that happens regularly of human staff that comes to visit the factory now. Some people just got to move on from their current career. Targeter. It's something that's been developing over time. Functionally. Unless absolutely destroyed. Which is unlikely. Some hitching in the scanning there. We could have a dummy targeter that is always used if there's not going to be a targeter, which would prevent us from having to do if it's null checks. The lore and concept of the character is my own. The art for the character was done by Animesh Studios. I believe the rigging was Inkjack and the artist was Dendy. They did a fantastic job. No, the elements of the color scheme are actually tied to elements of the lore that primarily people that were around for the Noida mod era of our streaming would recognize. Like the colors of the tubes, the colors in the hair, that kind of stuff. The fact that the angry eyes are the shade of purple. Yeah, let's get her catalog copy targeter. Just call this behavior. Behavior dot regular. Okay, so the assumption is there will be a dummy targeter that we create. And as such, we are going to do with the assumption being You can have just a dummy targeter. It does nothing. It's a popular graphics artist field. Okay, this allows us to have a dummy targeter that we can always just say its targeter is targeter, and that will do absolutely nothing. Because then, when we are dealing with a behavior, there is always a targeter. There should always be a targeter, and we can copy it because it'll be nothing. Doesn't even need to be cataloged at that point. Yes. Okay, so then if that way, what that will mean is we don't need to worry we could have two separate functions. Every behavior could be a group of behaviors. And it not having content of the group means that it doesn't need to do anything. But what that would mean is when we're acting, there is its own action, its own internal action, and then it would iterate over the entire collection and have them act. No, I think that should be an explicit type. I think behavior group should be a type. Because I don't want to have a behavior group that has its own action and have to deal with the convolution of that. That every behavior could actually have sub-behaviors that have to happen after its own behavior. That is, the intent of having behavior groups is so that we don't have to have that layer of convolution there. It's, if I want a behavior group that does A, then B, then C. I did see that that somebody to that name followed on Twitter just now. But if I wanted to do A, then B, then C, I don't want it to be this grouping entity does A, and then it contains entities that do B and C. It should be the group does nothing by itself, and within it is A, then B, then C. Yes. That will work. We'll come back to groups later. No, actually, we need to deal with groups right now. Not with urgency. We just should. So from our diagram, the reason that we have a behavior group is this is a segment. This is the equivalent of the segments there. So for a behavior group, all we need to do to create it is just pop all of the behaviors that are in it that were from the inventory into that behavior group. Yes. I also need to come up with a namespace to put all this stuff in so that we don't get conflicts. We'll get to that. Kind of hyped. We're doing stuff. Extends behavior. And a behavior group can have a gate key. It has a targeter, but it doesn't care about that. It is duplicating its base behavior. So when a behavior group is instantiated, it's going to have an initialize inside of it. And that initialize is going to instantiate its list. It's going to use a list and not a stack in this case because a behavior group ignores gates within it. Doesn't matter if I load a gated element into it, it ignores those gates. Because, again, this is something that I am prefabricating. These are things that get loaded into the catalog. I should not and do not intend to make a behavior group where within it is another layer of gating. That is convolution we don't need. If I want to have the behavior group have gates, it will be at the start of the behavior group. Otherwise, I need to have logic that goes inside of a behavior group and breaks it apart and tries to reconstruct things, and that gets wonky. Hey there, Corrupted. Not really cyborg, more droid here. Let me show you folks. If you look, there aren't any squishy bits. The heart looks like a heart, just, for aesthetics. That's actually the Nano core. That is the entirety of me. That is propaganda perpetuated by competitors of Catbot Corporation, James. The correct term is nano paste. Which is entirely safe for human beings and for use in the household when it is contained in a Catbot Corporation product. Asterisk, 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 asterisk. Happens. So make this just for expediency. Here it's a behavior group. And do that. That can't be right. It's not at all gray. Wait, I mean, that never happened. Behavior, behaviors, just a property, so it has to get set. New list of behaviors, nothing special about it. Group. Okay. Reach loop. For in group behaviors. Add if you're not familiar with the broadcast, you're new to the stream or similar, one, do not hesitate to ask questions or chat with me. I will try to get to it. I do get kind of focused on what I'm doing, but primarily what you're hearing is stream of consciousness of me programming in the game. So I do have time to periodically look up and chat with you. You are not interrupting. You spell behavior. It's suddenly bothering me. Yes. Log behavior. It is a behavior. Okay, so when we're duplicating it, we go into that and we duplicate all of the behaviors that are part of it. Then when we do act, virtual, it doesn't have to be overridden, but it should. that overrides. It will do is another for each. That in behaviors. Delta. Again, we're going to have to work out a way of subdividing delta. Is every time we do not want it to be that every time we call into that every piece of movement that we add, I don't necessarily want that to fully accelerate. But we'll see how it plays out. Like, for example, if this behavior group contained move in a straight line twice, then what's going to happen is that it will double up. But that's not really any different than normal. Let's table that. Okay, so we have behavior groups now. Behavior groups can still have a gate. So what this is going to allow us to do is have things like split into 3 and move as a spiral, or move as a spiral and split into 3. But in general, ultimately the same. It just changes when the direction calculation will happen and when the split will happen. Behavior groups will also act as the segments in an entity. So right here, its behaviors will be those segments. And when we're creating an entity, we set its base behavior, which can in turn be a behavior group. Which can either be something that is loaded into the movement catalog as a unique type of movement, or that could be made entirely unique to the entity itself. But no, I think that's okay, because we'll always have the source object. Yeah. Thinking. Oh dear. Okay, so we're loading textures in the catalog. This is the blob's texture. This is the wind-up mouse's texture, the yarn's texture. The player texture. Not using any of it just yet. So now we've got move straight line, which is a behavior, and it's going to have a override act. It's base class. Say just in case. We just do Not on an override. But on constructors, we can do that. Okay. Syntax. I added another like 10 songs to the playlist. Good stuff. Found some good piano and some decent cello stuff. Some more piano, I should say. So it's going to check its targeter. By calling the base action, and go into a behavior in the same way in a group. You can say you'd always do this just to be sure. I don't think we should be calling the base one here. Because not all of them care. Like, not all of them care about their targeter. We could do it as expediency. Okay, so what I'm contemplating right now is targeters are present for a reason, and the way that they work is steady. Like, they always work this way. You call update on them, and then a movement may or may not do something with the contents. But one possibility is that is down to each individual movement. They may not care about the targeter at all. But well, that ultimately comes down to each individual one. I should make the movements function even if there isn't a prior target. So it comes down to each individual behavior as to what it wants to do with the target, which means I don't need to call the base. Which is why I think this should actually be abstract. There's no such thing as just a behavior. So they all have to implement act. And they will do their own thing. So targeter, update targets, entity, and delta. Now, this targeter could then edit that, but there's nothing about move straight line that cares about what the targeter does as far as entities. But it will check with the targeter and say, what is your direction? We are not going to do this the same way. Like, this is not going to be how we do it. We are going to be setting a an intended change in direction on it, or at least essentially a current projected direction kind of thing, but a projected movement. So each one will keep adjusting things. We'll see how it ultimately plays out, because I do want some movement types that might say, hey, take all the movement that we've done up until this point and rotate it slightly. So like, drift right kind of thing. Or left, or whatever, drift towards target, so that all of the prior movement is still being taken into account, but you might get a bit of curvature. So we would not be directly adjusting the position, but for expediency, we're gonna. 0 times times targeter direction as a float one type conversion. So C# likes to use doubles, Godot likes to use floats. This is one of the only places we're going to be using Godot objects, because ultimately we're going to end up translating it into a Godot position. I may change my mind on this and use a tuple of doubles, just so that I only have to deal with it at the last moment when we mess with the multi-mesh or similar. But for now, we're keeping it like this. It gives us an opportunity here. Okay, so that's what move straight line does. We have a target random direction that if it's currently 0, it's going to essentially spin the wheel and set it. Behavior duplicates the targeter. So then in the catalog, we load targeters, we have target random direction. We load behaviors. Ooh. Straight line. And targeter is equal to load get targeter target random direction. Okay, so we have movement random direction. So then we've got static load entities. Right? Entities to null it. Yeah. We need a collection. Textures first, that's fine, then targeters, then behaviors. Okay. I could just remove this check. Once again, if that gets messed up, that's because I messed up. I could have debug asserts in later if I need to. New entity. I need to set with entity. Behavior is equal to behavior random direction. So then it doesn't have behaviors. Behaviors is something that gets set after the fact. Usually an individual entity is going to have during like a spawner setup is going to have its base behavior adjusted. It's going to be converted into a grouped entity that contains its original base plus anything that came after. Now, there's also the possibility that that won't be the case, that it will be base behavior and then a segment. But I'm doing it this way because what that means is you can set a series that are effectively permanent. The mouse will always move like the mouse first, but if I put a spiral right after it that doesn't have a preceding gate, the mouse always moves like a mouse and spirals, regardless of what follows. Okay. And let's see, entity. As a texture key. Okay. Equal to texture. Okay, so we're going to be able to load the entity here. We need a get for entities. Entity string as a key. Catalog. Entity. Take entities. What's this one called? This one is called Alluvion, and there are 3 musicians in it. If you're ever curious about the music, I do have a link to the Epidemic Sound playlist that I use, which would let you see which songs and artists are involved. Hey there, Sleepyhead. Welcome. In catalog, I load entities. Oh. String entity nanoblob. I wonder if I actually still need to use these. We're gonna keep it that way. Godot likes a very particular syntax, and I think we're still gonna need to do that when it comes to files. Oh, good to hear there. Glad it worked out. Entities. That. Entity. This should not explode. Didn't work. They're not generating anything. An instance of targeter because it is an abstract class. Where in the stack is it? Just so I can get a... Instantiate a copy. Should never be instantiating just a targeter, though. Random direction. Okay, no, we need... Because if we say type of T, that's always going to be a targeter. We want to return it as a targeter, but we want it to be this specific type. Yeah, it's probably the problem. It's totally the problem. It'll work this time. Didn't work this time. Same thing. Well, no, different thing. Different thing. Object reference not set to instance of an object in get from catalog. It's get entity. Oh, get into... Oh. Do you see where we're configuring the entity collection? Load entities. Okay, they're not moving how I want them to, but we are now loading it properly. At least, in theory, we're loading it properly. It's a target random direction, gets a move straight line. Target random direction. We update targets. If we need to, we rotate it. So go there. Here. Into the debugger. Go to okay, never calling that. We look in entity. That would stop it from calling act. Let's turn those off for now. Oh. Still not moving. They're not generating errors, but we're not moving. I should put the debug break. I should have put the breakpoints in. So never getting update target. And you're never getting to act. Okay, so in the entity manager, we're generating them. We add them to entities, and then for each of the entities, we're going to call act with the delta that we are supplied with. In no base behavior. Okay, I have an idea. To continue, move breakpoint, continue. Goes out gracefully. Back in. Go into entity. entity is copying. We are not copying the base. About 4 more minutes, Alexa. You know, potentially a little bit more based on how much I bumble over my closeout and if I get too distracted here. So, base behavior is equal to entity catalog copy behavior. Behavior. Building, building, building. Haha! Ah, progress. Yep. I've been trying to go a little, start a little earlier. Hey there, Minty. Just in time to see today's progress. We saw some of this in the last iteration, but this is actually using the catalog logic that is, where we want to be. Oh. Think we'll need to do that in the multi-mesh. We need to make sure that we have a setting to flip it. Have that already. Sure. Mesh. Processing. Okay, this is why we need the moving in this direction portion. But let's short circuit this. So this is the scaling vector. This is a float. Scaling x is equal to 6. E dot I think we're going to have like some facing parameter here. But for the time being. Wait a minute. Suffix usually, isn't it? Yeah. Thought it said prefix, but Warnings. All right, one more little check, and then we're probably going to wrap up here. Yeah, they're always facing left, but by default, I'll have to verify this because they're facing the wrong way. Weird that a positive transform would be flipped like that, but I may have something set wrong. In like if I do that. One more. Why are the blobs facing left all of a sudden? Oh well. We'll get there. All right, we made some progress today. We've got the skeleton of behaviors. We have a working example of a behavior and a targeter. We have we don't have gates yet, but that's going to be next. And I've still got to figure out why the mesh renderer has got them flipped. But we'll figure it out. Anyhow, I hope everybody had a good time watching today. If you like what you saw and would like to see more, remember to like, follow, subscribe, all that sort of good stuff. It will help you find content like this in the future, and it helps the channel grow. All that said, I do hope you have a good rest of your day, and I'll see you next time.